Okay, hi, here we go, our first video lesson. It's going to be on exponents today. This should be a review for honors class, so here we go. I'm going to go through the first couple of slides kind of quickly. Feel free to stop me, rewind me, slow it down. So here we go. Exponents. Exponents are an algebraic expression that are composed of two numbers, a base and an exponent, and together they form what's called a power. So if we look at what an exponent means, it really, this algebraic explanation is the number or expression that represents how many times a base is used as a factor in repeated multiplication. So fancy way to say, I'm going to take my base, which in this case happens to be a 5, and I'm going to multiply it by itself as many times as the exponent is. So in this case it's 5 to the third, which means that I'm going to take that 5 and I'm going to multiply it by itself 3 times. We'll be using a calculator later, but I just happen to know this one's 125. There's two special words for, there are special words for a squared and a cubed. So if you have a power of 2, that's considered squared. If you have a power of 3, that's going to be called cubed. So just some special words for those two instances. Real quick, let's just go through this. 7 times 3, we're not going to use calculators right now, we will use them later. That just means 7 times 7 times 7, because the base is a 7, the exponent is a 3, 343. 10 to the 5th, 10 is considered a base 10 because the base is a 10. And I'm going to multiply that by itself 5 times. And base 10s are super easy, you don't ever need a calculator for a base 10. I'm going to start with the number 1. Because I have a 5 as my exponent, I'm going to have 5 zeros. If I had a 6 for the exponent, it would be 6 zeros. If I had a 3, it would be 3 zeros. So base 10s can be pretty easy, or are pretty easy. Let's do this 3 to the 4th. I'm just showing you some ways, some strategies if you don't have a calculator. I can group these together because they're all the same number and it's all multiplication. So I can do 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. So I'm just kind of grouping them together. Here I have 6 2's. And I'm just going to go straight down the line and multiply them. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 is 64. Fractions. If you have a fraction that is inside a set of parentheses, that means the numerator and the denominator both receive that exponent, which is a 3. So let's just take a look at that. That means I'm going to do 3 times 3 times 3 on the top, and I'm going to do 4 times 4 times 4 on the bottom. So 3 to the 3rd, that's 9 times 3 is 27. 16 times 4 is 64. So that's just a real quick review of what exponents are and how they work. Here we have an extra thing that's being added to your power. So we have a number that sits in front of your power, which consists of this x raised to the 2nd. And that special number is called a coefficient. And what the coefficient is doing to this power is multiplication. So order of operations, once you did this power, you would multiply whatever it is left by, or whatever you get by 4. So it's just really important that you can identify what's a base and what is a coefficient. Wow, excuse me. So let's just label these. We're not going to do anything with them. We're just going to label them. So here's my power, x to the 5th, which means that 4 is my coefficient. And I'm just going to abbreviate. Excuse me. X is my base, which means 5 is my exponent. Down here we have this 2. It is not getting the power of 8, only the n is. So 2 becomes my coefficient. And I'm abbreviating again. N is my base, and 8 is my exponent. This doesn't look like it has a coefficient, but it actually does. I like to say 1 is the loneliest number in algebra. It is always everywhere. So there is actually a 1 sitting in front of here. We just don't bother to write it, because when you multiply something by 1, it's just itself anyway. But there really is a 1 that's sitting here. So this power does have a coefficient, and the coefficient is a 1. Again, just abbreviating, y is my base, and 2 is my exponent. So when you start to look at something like this 5 is no longer a coefficient because it too has an exponent. So you see the difference between these? This 4 does not have an exponent, so it is just a coefficient. But this 5 has an exponent. So now this 5 is considered a base because it has an exponent attached to it. So does the a. So the 5 and the a are bases, the 2 and the 3 are exponents. So looking at this first one, 4 to the 8th, x to the 3rd, the 4 and the x are both coefficients. So I'm sorry, I said the wrong word. They are bases. There are no coefficients here because it has that exponent, it makes it a base. And that means my 8 and my 3 are both exponents. 2 has an exponent, so it becomes a base. And v has an exponent, so it is also a base. Again, no coefficients here. 2 and v are both bases. And the 3 and the 4 are both exponents. Same thing down here. 6 and m are bases, and 4 and 7 are exponents. That's important when we get down to this product rule for exponents. I'm going to explain why this works. But if you are multiplying powers with the same base, you are just going to end up adding the exponent. You notice the base stays the same and you're just adding exponents. So let's kind of look at why that works the way it does. So think about this. If 3 to the 2nd means 3 times 3, what does 3 to the 2nd times 3 to the 2nd mean? Well, that means that this is 2 3's. And I multiply it by this, which is also 2 3's. How many 3's do I really have? So I'm just multiplying straight down the line. I really have 4 3's. And if I'm multiplying the same base by itself, then I can just count how many of them I have, and that becomes my exponent. Like here, I had 2. That's why my exponent is a 2. So here I have 4 of them, and 2 plus 2 is 4. So I'm really just counting how many I have and making that my exponent. If you took your calculator and did 3 squared times 3 squared, you would get the same thing as 3 to the 4th. And you can test me on that on your calculator, but this is 9 times 9. And if I broke this down, it also is 81. So the reason that you can add your exponents is you're just counting how many of those bases you have. The trick is, though, the bases have to be exactly the same. So let's look at this, and I'm just going to break it down. 4 to the 2nd means I have 4 times 4. 4 to the 5th means I have 5 4's. How many do I really have? Well, I have 1, 2, 3, 4, 5, 6, 7. I really have 4 to the 7th. Oops, sorry. I have 4 to the 7th. And that's 2 plus 5. I have 4 5's. I have 6 5's. There's my 4. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I really have 5 to the 10th, which is the same thing as 4 plus 6. So you're really just counting how many you have. You can stretch it back out and then condense it back together. So here I have 2 7's Here I have 8 sevens, so how many sevens do I really have? I have 10. Here I have 8 y's and then another 5 y's. So how many y's do I really have? I have 13. So when you're multiplying the same base, it has to be the same base, all you have to do is add their exponents together, and that's kind of the condensed form of it. It's not going to work on these because they're not the same bases. So that's why earlier we were looking at what's a base, what's a coefficient. You have to be able to identify what's what. The bases, when you identify bases, they have to be exactly the same. Because if I had 2 3's and 5 2's, I'm not even counting the same thing anymore. So that's why the bases have to be exactly the same. So let's just look at them. Here's kind of the rules. In order to multiply powers, the bases must be the same. So identify the base. You have to know what the base is. If they are exactly the same, you can add the exponents. If the instructions say simplify, do not do the math, and if the instructions say evaluate, you can do the math. So we're not going to do the math right now. I know that sounds kind of funny. We're just going to simplify them down and rewrite them so that they're smaller, because that's kind of big right now, okay? So let's just look at this one and break it down. 3 does not have an exponent, so that makes 3 a coefficient because there's no exponent on it. So I can just list that 3 here because it's just a number. It's just sitting there. It's got nothing to do with my powers. I have 5 x's and 2 x's. So altogether, I have 7 x's. This is simplified. This is not. I mean, that's just way easier to look at than this. So let's do this one. Here the 2 has has an exponent, so it is a base. So I'm just going to leave it as a base for now. I'm not going to do anything with it, and I can't put it with the x's because they're not the same thing. Now I'm just going to count how many x's I have. I have 3 x's here and 5 x's here, so I really have 8 x's. 8 has a exponent. 8 has an exponent. That makes my 8 bases. So I can add their exponents because if it has an exponent, it's a base. So I have 2 8's here and I have 7 8's here. So I have 9 8's altogether. I have 2 b's, I have 3 b's, so I really have 5 b's. So this is going to be 8 to the 9th, b to the 5th. That's just kind of breaking down what the logic means, or how it works. So let's look at this. 2 and 4 are not bases because they have no exponents. So now they're just coefficients. Can I multiply 2 times 4? I can, because they're just numbers. Coefficients are just numbers. So 2 times 4, that's 8. And now I'm just going to count how many bases I have. I have 5 b's, I have 3 b's, I have 8 b's. Down here, 5 and 3 do not have exponents. That makes them coefficients, which means I can just multiply them. They're just numbers. So 5 times 3 is 15. I have 3 s's. Does this have an exponent? It does. How many s's do I have right here? I don't bother to write it, but I have 1. So if I have 3 here and 1 here, I'm going to make this 5 look a little different. I really have 4 s's. And then I have 3 t's and 2 t's. So I have 5 t's. So this is 15 s to the 4th t to the 5th. One last one, or last page. 3 is a base here because it has an exponent. 3 is a base here because it has an exponent. So I can add these two together. I'm going to keep my base the same. Notice I don't multiply. This does not become a 9. It stays a 3 because it's a base. It's not a number, it's a base. I have 5 here, I have 4 here, I have 3 9's all together, or 9 3's, I said it backwards. D to the 7th, D to the 7th, I really have 14 D's. 7 squared and 5. 5 is just a coefficient, and it's got no exponent to it, so I can't put it together with this, because this is a base, this is not, it's just a number. So I'm gonna keep my 5 separate, and I'm gonna keep my 7 to the second separate, because they're not the same base, so I can't put them together. I have 8 V's and 6 V's, so I have 14 V's. And I'm just gonna leave it like that for now. My 9 and my 2, because they don't have exponents on it, they're just numbers. So they're just coefficients, which means I can multiply them. So 9 times 2 is 18. I have 9 K's, I have 3 K's, I have 12 K's. I have 6 M's, I have 7 M's, I have 13 M's. So rewind that, look at it again if you need to, but you really need to know the difference between these two things. Because this has an exponent, it is not something I can put with this 5, because now they're not the same thing. This is just a coefficient, no exponent. This has an exponent, which makes it a base. So see the difference there. And like here, I can multiply the 2 and the 4 together, because they're just coefficients, they're just numbers. And so they're not considered bases, which means I can just put them together, because it is saying 2 times 4, and then b to the 5th times b to the 3rd. So you do just have to be able to see if it doesn't have an exponent, it's just a number. If it has an exponent, it's a base, and it can only be put together with bases that are the same. So if you have any questions, let me know. You do have a worksheet to do. I think there are quite a few problems on there, but I did supply answers. We are not going to do the entire worksheet. Just do a few, make sure you got it, do a few more, and if you have any questions, reach out and we'll talk. So thanks, let me know how it goes, and I'll see you next time.